Welcome to another science exploration guide. Today, we're going to explore about the potential energy, different types of potential energy with relevant examples for elaboration. It's a truly fascinating concept, so let's get right into it. So here is our roadmap for today's explainer. We're going to be breaking down gravitational potential energy, elastic potential energy, and chemical potential energy. But first, what exactly is potential energy? Basically, it's the energy an object has just because of its position or its state. It is, quite simply, stored energy. Even if something is completely still, it can hold a massive amount of power just waiting to be unleashed, all depending on where it is or what it's made of. All right, let's jump into our first category, gravitational potential energy, which is stored energy that comes purely from height. Now, this specific type of energy relies on two very important things. Step one is height, literally how high the object is from the ground. And step two is mass, how heavy that object is. Because gravity is constantly pulling down on us, the entire concept of gravitational potential energy hinges completely on these two factors. To put that into perspective, a heavier object positioned way up high has a ton of potential energy. But if you take that exact same object and place it flat on the ground, where the height is zero, its gravitational potential energy drops to absolute zero. I mean, it literally has nowhere to fall. You actually see this everywhere in the real world. Think about a heavy book just resting quietly on a high shelf, or millions of gallons of water held back by a massive dam. A person standing on a ladder, a massive boulder perched on a hill, or that breathless moment when a roller coaster pauses right at the very top of the track. In every single one of these cases, the second that object falls, all that pent-up, stored energy instantly becomes motion. Let's do a quick quiz to test this out. Which of these do you think has more potential energy? A ball just resting on the floor, or that same ball sitting up on a table? If you guessed the ball on the table, you hit the nail on the head. It's at a greater height, which instantly gives it significantly more potential energy than the one stuck on the floor at a height of zero. Okay, let's look at that second factor, mass. Imagine a steep hill. If we have a heavy rock and a small stone sitting at the exact same height on that hill, which one has more potential energy? It's the heavy rock for sure. Since their height is identical, the heavier rock's greater mass means it's packing way more stored gravitational energy. Moving right along to section 2, elastic potential energy. This is energy stored through stretching or compression. The rule here is super straightforward but incredibly cool. The more you stretch or compress an object, the more potential energy gets stored inside of it. By physically altering its natural shape, you're essentially loading it up with power, just waiting for the moment you let go so it can violently snap back. Think about pulling a rubber band tight or pushing down on a heavy metal spring. Drawing a bowstring back before you shoot an arrow is pure stored elastic energy. Even clicking a tiny pen spring or jumping down onto a trampoline mat, you're compressing those materials and storing the energy that eventually pushes you back up into the air. So, applying that rule, let's ask, which of these holds more hidden power? A taut, stretched rubber band or a loose, relaxed one? Naturally, it's the stretched rubber band. The physical act of stretching it is exactly what packs the energy inside the material. A loose rubber band is just chilling in its resting state, so there's no stored energy there. Here's another one to make sure we're keeping our categories straight. Where is elastic potential energy actually stored? Inside a compressed spring or in a stone lying on the ground? It's in the compressed spring, absolutely. Remember, elastic potential energy lives specifically inside stretched or compressed objects. A resting stone on the ground doesn't fit that description at all. And that brings us to our third and final category, chemical potential energy, which is energy stored right inside chemicals. Now, unlike gravity or elasticity, this energy is completely invisible to us. It's stored in the chemical bonds of the objects themselves and gets released during a chemical reaction. We literally rely on this every single day, drawing power from things like batteries, the food we eat, vehicle fuels like petrol and diesel, and combustible materials like coal or wood. You see this constantly. A battery in a torch uses a chemical reaction to create bright light, just like a toy battery causes movement. The food on your plate gives your body the stored chemical energy you need to walk, run, and just live your life. And the petrol in a car, it combusts to forcefully propel that massive vehicle down the road. Let's test this concept out. Between these two options, where is the chemical potential energy actually stored? In a battery or in a moving bicycle? It's the battery. A battery actively stores chemical energy inside its casing, which it then converts to electrical energy. That moving bicycle represents kinetic energy, the energy of actual motion, not stored chemical energy. Okay, last question for this explainer. Why exactly do we get energy from our food? Is it because the food has chemical potential energy or because it has kinetic energy? It's because food has chemical potential energy. Your meal isn't moving around on the plate with kinetic energy. It's packed with complex, stored chemicals that our incredible bodies break down to do physical work. So, to wrap this all up, potential energy is simply stored energy waiting to happen, whether it's from gravity, elasticity, or chemicals. Keep an eye out for it in your daily life. If you find the video informative, please like the video. Thanks, gang.